Right. Let's do step 5 now. Yeah, let's do step 5. Can we do step 5 now? 5 and 6 in one go, if that is all right. The book is like very easy to understand. When you look at the book, right, it's very easy to understand. It's really easy. Like it is extremely easy to understand. You know what? I'm just going to pause for some time. I'll just pause for some time. I'll come back on the stream, and then I'm just going to show like how easy it is. So if you want to see, you can see. If you don't want to see, that's completely fine. Currently, I am finishing the chapter 1.2 for my aerodynamics. Right. Hi everyone. While I was finishing chapter 1.2, like no, chapter 1.2, I decided that screen flood wrote my book. So when you look at the book here, so obviously from the name takes into significant to understand what's going on and stuff. But when you look at the book, you see that it's not like way too many English, way too many words. So when you look at it, say for example, if I were to open the were to the figure font in Canva, for example, you see that they have like way too many words, right? So because they have way too many words, it makes it very confusing, it makes it very difficult to understand. You know, what every word is defined. You have to read it. Sure, you can read ChatGPT or something, it's fine. But you have to like still understand what's going on because there's way too many English. On my book that I'm studying, when you look at the book here, it has English but not as much. So we're mostly focusing on the maths, mostly focusing on the derivation, mostly focusing on the steps needed to perform it. Because what my main aim is that the engineering students or like the engineering students and physics students, not only they're going to understand how you perform it, but actually utilize it in real world, because that's very important. If they can't utilize it in real world, I don't think there's no point in doing it. Because to utilize it in real world, only the way they can do it is understand. And if they don't understand it because they're written in English, those are redundant words and stuff like that, which makes it very difficult to understand. And so my plan is that I'm going to keep it as less English as possible, but more math. And I'm going to have English, technically I'm going to have English, but the English should mostly be on the keywords, the core concepts, like what is it trying to explain? What is it trying to say? What is it trying to understand? And there will also be Python programs. There will be Python programs 100%. But the main thing is not the Python program, but the math. Yeah, the maths used to actually solve this problem, right? So that's my plan. That's my entire goal. And obviously, it's going to take a long time. But my plan is that for now, probably I'm just going to finish for a fourth chapter. It's going to take a long time. Definitely, it's going to take a long time. Because what I'm doing is I'm actually doing 8 courses. So 6 for undergrad courses, 2 for graduate courses, all in one course. So it is going to take time. But quite a lot, but the book will take me. I'm very excited for the book. I'm really excited. I'm really, really excited. The other book is also coming up in cybersecurity book that's best for computer engineering students and computers and computers. This is best for physics and aerospace engineering.
End document. I like how he look. It's very easy, right? When you look at the book, like anyone will understand what's going on. Like there's no way that you will not understand what's going on. Anyone will understand what's going on. Like sure, definitely, sure. Like you have to, read and stuff like that. You'll not just see and be like, oh, I understood. It's not like that. You have to read and you have to get through the concepts and stuff like that. But when you look at the book, it's like minimal. Like it's not like way too many words like quantum mechanics has. Like look at the words. Look at the book in quantum mechanics. That's like way too many words. Like you don't want that. You want like less words. Me. We go to because imagine like when I said this to Valentina, I don't think she cares because she thinks that writing a book is easy. Because someday someone will ask you, well, explain your book. What will you say? Right? What will you say? Because writing a book is not the hard part because I mean you have AI and whatever. Because writing a book is not the hard part. The hard part is well, what did you understand? If you didn't understand anything, I don't think there's no point in you writing the book. Kalman filter combines mathematical predictions, sensor measurements to estimate the best possible rocket state. The first stage of the Kalman filter is called the prediction step. The prediction step estimates the future rocket state using the mathematical dynamics model. And so predicted state estimate. So the predict. Okay, wait, stop. This is what Kalman filter prediction step. What's going on? Just explain what's going on. One by one. Just easy, easy, easy. What is going on? So there is the prediction state estimate. So this is the Kalman filter prediction state estimate, prediction step. So step 5, Kalman filter prediction step. The Kalman filter combines mathematical prediction and the sensor measurements to estimate the best possible rocket state. The first state of the Kalman filter is called the prediction step. The prediction state step estimates the future rocket state using the mathematical dynamics model. Okay. So what does Kalman filter do? So step 5.1, what does Kalman filter do? So it combines the mathematical prediction. It combines it, the measurements that it's got that the sensor measured to estimate the best possible rocket state. So Kalman filter combines the mathematical equations, the mathematical steps, and the sensor measurements to estimate the best possible rocket state. In order to estimate the best possible rocket state. So they explained here. So you see that x hat of k minus 1. This is called the predicted state estimate. Means the x is the state vector. That's the rocket condition. Hat means x estimated value. So this is the estimated value for x of k. So it's trying to estimate the true state. So this is the rocket's estimated state measured by the computer. K is the current time step. Yeah, that I know. And this is the previous time step. So what's going on is that the 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 system or the sensor measured the estimated true state based on what the computer measured for the current time step and the previous time step, and they got a prediction. So they took the information from the current time step, they took the information from the previous time step, they got an estimate, and from the estimate value that they got, they'll output a certain prediction. So prediction state estimate. Prediction state estimate. So predicted state estimate is written as a predicted state estimate written as x hat of k minus 1. Wait, I have one question. Like, forget chapters. Wait, forget chapters. The course that I'm doing, it doesn't look possible to finish entirety of a chapter in 1 week or 10 days. Like, considering you have to go through the chapter, go through the thorough understanding and stuff, right? Is it normal? Like, this course usually has a combination of what courses? There's literally one full university course. That's another university course. That's another university course. That's another university course. Another university course. Another university course. So these are graduate level courses. Estimation theory, optimization. Do we have? Yeah, control systems is a graduate course, right? On engineering. Yeah, yeah, I told you. Control systems 1 and control systems 2. Seven, eight, two, five. See, I am technically doing graduate courses. Yeah, I've done that. That's physics 2820, computational mechanics, classical mechanics. Yeah. Look at flight dynamics. Do they have flight dynamics? Mine engineering. Not fluid dynamics, flight dynamics. They don't have it. Estimate. What is estimation theory? Estimation theory, mine engineering. Holy shit. Optimization. Non-linear and linear optimization. Math 6202. What course is that? Holy fuck. Non-linear and linear optimization. Shit. That's a graduate course? So I'm literally doing a graduate course here. Holy shit. I am literally doing a course here. Think about it. I'm doing a graduate course. And somehow I'm not good enough. Who would have thought I didn't even finish undergrad? Dude, how is she so popular, man? The comments that these people leave are so cringe, man. Shit. Cringe. Like, very cringe. Very cringe. So, this is the prediction for the current state vector time step and previous state vector time step. What's this? The predicted state equation is that on the rocket state vector, oh, I know what covariance matrix is. Yes, I do know what covariance. Thank God I know what covariance matrix is. Just snip that. I'm going to procrastinate as less as possible so that I can get like 100, like probably like 20 clips. I can easily get 20 clips. Imagine like mass uploading like 20 clips. Wait, shouldn't it be 5.2 first? Wait. Can you explain 5.2 first, then 5.3? So you saw that x hat of k and k minus 1. Oh, I didn't see that. Oh, okay, yeah. Obviously, it was terrifying shit. So the state prediction general equation is what? So the state prediction general equation. So state prediction general equation. So x hat of k minus 1 is equal to a x hat of k minus 1, k minus 1, right, a x hat of k minus 1, k minus 1 plus b u of k. So this is just where will the rocket be? So this just measures the position of where the rocket will be at the next time step. The position, okay, actually, this measures, this predict where the position of the rocket will be at the next time step. So this utilizes the previous rocket state, the previous rocket position, whatever, and based on the information the model or the sensor has retrieved from the previous rocket state, they're gonna use that information and measure their next rocket state. And A being some physical change like altitude or velocity or mass, whatever. Utilizes the previous rocket state to measure the next or future rocket state. A being the physical change like altitude or velocity or mass or you know, yeah, being the physical change in a rocket like altitude, mass, velocity, whatever. All right. The next payment, the subscript, meaning prediction at time step k using the information from time step k minus 1. So what is this k minus 1? So prediction at time step k using the information from time step k minus 1. So the left side means predicted rocket condition for the next time step. The right side, that's the first part. Well, we all know what that is. Let's move to. Oh shit, we're still in 5.3. All right. So the entire equation ends up x prediction of k minus 1 is equal to a of. So the future rocket state is equivalent to the natural rocket motion plus the control input effect. So then, therefore, we're going to have x hat of k minus 1 is equal to a x hat of k minus 1 plus bu of k. Now we ask what exactly is